when we're coming up with an experimental plan to try to measure something, we had to try to identify a few different things before we start our test. So the first thing we want to do is we want to look into what type of variables may affect the outcome of our experiment. So some of the examples of these different types of variables are shown below. So a variable can be both discrete and discrete or continuous, right? So discrete variable can be only set to certain values. So you can think of like a discrete variable as being like, is there yes or no, or is it like on a dial? Is it like a specific setting on a dial? A continuous variable is anything that can be set to any value within a given range. So you have much more control over something that's a continuous variable versus something that's discrete. Okay, an independent variable is a variable that is not influenced by another variable. Like the most common independent variable is time. We cannot change how long time is, but time can affect other systems. So a dependent variable is a variable that's influenced by other variables in the measurement system. Okay, so depending on the other variables that are in the measurement system, the dependent variable will be a function of those multiple other variables. Okay, um, and then we have controlled variables. Is a variable that is held constant throughout the experiment to try to eliminate its effect on the experimental results. A parameter is a set of controlled variables that remain constant during the experimental test plan. So controlled variables make up parameters, and then extraneous variables are variables that are not controlled but may still influence the experiment. These should be monitored and eliminated whenever possible. Okay, so we're going to give a little example problem here just to explain how these different types of variables may influence a specific experiment. Okay, so you have a very busy friend that enjoys tea, coffee, hot chocolate, right? They know that they like to brew that beverage at 200 degrees Fahrenheit plus or minus 2 degrees, right? So at their workplace, they have access to 3 different microwaves, 2 1,000-watt microwaves and 1 800-watt microwave, and they have access to 6 identical ceramic coffee mugs. All right. You have an instant digital thermometer that may be used to determine the temperature of the water after you remove it from the microwave. Okay. So you want to do an experiment. You want to minimize the amount of time to heat exactly 1 cup of water to the desired temperature using the equipment you have. Right? So basically the equipment that's available to your friend at work. So for this experiment, you want to list the dependent variables, all the independent variables, a set of control variables, and any extraneous variables. For all variables, note if they are discrete or continuous. Right? So what I'd like you to try to do is stop the video for a quick second here. Alright. And I'd like you, alright, to try to design a test plan to determine what is the optimal amount of time to minimize to determine the minimum time required to heat exactly 1 cup of water up to that desired temperature. Alright, so here's a test plan that I developed to determine the minimum amount of time to heat up 1 cup of water with the microwaves that my colleague had available. Right. So first thing I would do is I would fill all 6 cups with 8 ounces of room temperature water. I would then, using only the two 1 kilowatt microwaves at maximum power, I would heat up each mug individually, all right, at different intervals. All right, so I would set one mug for 1 minute, heat it up, another mug for 2, another mug for 3, another mug for 4, another mug for 5, and one more mug for 6. All right. Now, immediately after heating, I would record the temperature of the water. All right, and then based on the results from step 3, I would select a smaller time range and repeat steps 1 1 through 3 again to find a more appropriate time. Okay, so let's say that if I heated it for 4 minutes, it was too hot. For 3 minutes, it was too small, or the temperature was too low. I would pick times in between 3 and 4 minutes in order to try to find that optimal time. Right? Now, the different types of variables that play a role in this experiment include our independent variable. So our independent variable is not affected by any of the other parts of the experiment. It's heating time in this case. The parameters or control variables are the power setting on the microwave. We set that to be the maximum amount, and that's a discrete setting. The volume of water in the mugs, that was 8 ounces. That's continuous. Okay. Um, all right. The dependent variable is the temperature of the water in the mug. All right. And the other control variable we had was the type of mug. We're using a ceramic mug. All right. We're not using plastic cups. All right. Now, the extraneous variables in the experiment include the mug temperature. So is it if you repeat the experiment and the mug is still hot from holding the hot water, does that affect the next time you run the experiment? The other thing is we said to use room temperature tap water. Depending on the setting on your tap, it might have been different than what you're used to, and that could affect how long it takes to heat and cool. And so you could eliminate those extraneous variables if you added more steps in the experimental procedure. It may not be necessary for this simple of an experiment, but these are things to try to identify if you don't get clearer results. If you can try to identify extra variables and try to add those to your parameters, it could lead to much better experimental results.